And I think we're live, Tibbs.
Yay! Hello, folks. Hello, happy audience. So my name's Tibbs, and with me you can see Sebi. I'm going to be talking at you, and Sebi is going to be helping in the chat, putting up links that are useful, and reminding me if I forget anything. It's always a good policy, and sometimes it's necessary. So today we're going to be talking about learning how to do simple things with Apache Kafka using Python. Luckily, much of this will work for other programming languages as well. And in particular, we're using the Confluent Python library, and Confluent has libraries for other programming languages as well. I was at a conference recently where someone was explaining how to program Kafka with C#, for instance.
Yeah. I leave the stage and I will come back if needed.
Yeah, and I need to remember to point my cursor at the slides and not at the video window. So before we start, we're going to be setting up an Aiven account, and we're going to be using Gitpod to actually run our code. We're going to go through how to set both of those up during this session, but this link will take you to a page on our forum, which has an explanation of how to do it as well. And that's this page here. I won't come back to that, but that means that if I'm too fast or if you get stuck and need to go back a bit, this may help. So the agenda for today, I'm going to talk a little bit about what Apache Kafka is. We're going to talk about how to create a managed Apache Kafka cluster, and immediately I spot a spelling mistake because that's traditional. We're going to talk about using Python to securely connect to that Kafka, how to produce messages, and how to consume messages. So what's Apache Kafka? Well, I'm going to read this out. Apache Kafka is an open source distributed event streaming platform. Now, I'll come back to that in a moment. If you've been around in computing a long time like me, then when I was a new programmer, the way we sent information between systems was, well, eventually we wrote a magnetic tape. So we'd dump the updates to a magnetic tape. We'd send that probably by post to the person who wanted the updates. They'd read the magnetic tape and apply the updates. So this was an inherently very batch-oriented process by definition. It was slow, and it meant that you didn't get updates very often. As time went on, we gradually got the internet. We got the ability to send files around. I'm just worried that our video has gone. Okay, we were still doing much the same thing, but a rather faster pace. We could dump states to a file, a binary file often, and send that to someone, and they'd load it into their system and get the updates. Around about the same time, we began to get people sending messages, messages over sockets, over the internet, or on the same computer, and that would be sending messages that said, "Here is some updates." And you'd be sending them to someone and they'd say, "Hey, I got that." Or you might be broadcasting it to a whole group of people, in which case you'd broadcast it and hope that they got the message. But what you weren't doing was having the ability to have someone come along later and say, "Hey, I'd quite like to find out what messages happened in the past." So we now get back to Kafka. So Kafka comes from all of those experiences. It's open source, so it was invented by LinkedIn back in 2010, I think, to solve a particular problem they had with coping with a large number of events happening on their platform that they wanted to do things with quickly. They open sourced it very kindly, and that means it's developed in the open. It has the advantage that you're free to use it as you wish following the license. It also means that different companies, possibly even competitors, can all collaborate in improving Kafka. So you'll find that there are different people who provide managed Kafka services. They don't have to compete on the making Kafka better. They're just competing on the making Kafka easier to use. It's distributed. That means that it fits into the cloud very well. Kafka runs as multiple small nodes, multiple small services that collaborate, and that means that you can scale Kafka horizontally by adding more more services, so it can handle more data because there are more services distributing the data between each other. You can also scale it vertically by making each of those little nodes more powerful so it can do more stuff faster. So that means that Kafka scales very well and can handle a very large amount of data. It's also trying to be as near to real time as you can get in the cloud. So it's an event streaming platform. So the idea is that you produce messages and the consumers that are receiving the messages can consume them in almost real time. Proper real time, you have to have hardware and stuff. But the cloud, you can't do proper real time, but you can get near real time. You can read these messages as fast as is feasible across the internet. It's licensed under Apache 2.0. Apache 2.0 was was the first generally adopted open source license that also provided protection from being sued to patents in infraction and things as well. So it makes it a very safe library to use. You're not getting to get in trouble with anyone for using Apache Kafka in a legal sense. Now, that's all a lot of stuff. How does Kafka actually think? How does it work? Well, the basis of Kafka is a topic. It doesn't have to be called topic. You can give it any name you like. A topic is a collection of events. Now, I'm saying events. You might also hear them called messages. But as we'll see, there's a lot of similarity also to a log file, a series of log messages that you might get out of a system. So we have a producer who is going to send messages, events to a topic. We can have more than one producer writing to the same topic. We're going to ignore that for this presentation. So the producer writes a series of events to the topic. Note that their order is the same order that the producer writes to. These are appended to the topic. They're added. They're not going to go away. They're left in that order. They sit there, and the consumer can come along and it can read them. It will ask for them, and it will read them in the same order. So we're order preserving. Now, if you have two producers writing at the same time, those two producers will have their messages interleaved, but the consumer will still read them in the same order they were written, if that makes sense. That's all well and good. Here we are. We add another event, and the consumer will read it. When the consumer starts reading, it can choose where to start. Does it want to start at the front of that queue? Does it want to start with the most recent message? Does it want to start somewhere in between by specifying an offset or possibly a data time? If the consumer goes away and wants to come back and resume, the system is set up to remember where the consumer had got up to. So a consumer that falls over, that crashes and then restarts, is able to pick up from where it was previously, and that's really rather important. One of the real problems with traditional messaging systems is how do you cope when you restart? How do you make sure you haven't missed messages? That can be a very hard problem to solve. Kafka produces quite a nice solution for that. We can have multiple consumers, and when they read, they'll get the messages in the same order. One little extra thing, we can actually split a topic up into partitions internally. We're not going to address that in this session. And consumers can choose to read the whole of the topic. They can choose to read only parts of the topic, and they can choose to set up as a consumer group who will share messages from the topic. If you've got a lot of events coming fast, your one consumer might get swamped. It might not be able to keep up. So it can make sense to have more than one consumer sharing messages out between them. It's worth knowing that can be done. It's out of scope for what we're going to do today. Have I forgotten anything, Sebi? I think that was. So our first thing we're going to do is, because it takes a little time to run up, we're going to create an Apache Kafka cluster. But before we get to that, I get to do my bit of advertising Aiven, who I work for. I'm a bit biased here. So the reason that I think Aiven is interesting is that we provide one data platform for all the things you might want to do with data in the cloud. We are a trusted open source data platform. And we provide Kafka, Apache Kafka. We provide various other tools, including Postgres and MySQL, Redis, big databases like Cassandra and ClickHouse, and so on, OpenSearch. We do that across multiple clouds. We make it so you can switch clouds easily, and we make the pricing predictable, And we make it so that you don't have to worry about migration, upgrade, and backup, all the things that can take so much effort away from doing the work you actually want to do and leave you just spending all of your time managing Kafka or Postgres or whatever. So because it's easy, for me in particular, we're going to create our Kafka service today on our platform. It's not going to cost you anything because we have a free trial that you'll get enrolled into. So you won't even need to give credit card details or anything. There's no way we're going to charge you any money for learning about Kafka. So if you go to this URL, which is now in the chat, then you will end up at this page, which invites you to sign up with Aiven. I'm going to sign up with a new temporary account, just as you would. So I'm not going to. I'm going to take care not to sign into my normal work account because that would be too confusing. So I'm going to continue with email. But if you want, you can also sign in with Google, Microsoft, or GitHub. And of course, if you've already got an account, then please log in with that. So if I click continue with email, and by the way, if I go too fast at any point, do please complain in the chat. So I'm going to say my name is Tips, but I'm going to put today's date so I don't get confused about why I'm doing this. I'm going to give a variant of my email that means that I won't end up accidentally using I can't spell. And I'm going to give a really good secure password, which I'm just getting from over here. And I'm going to register with that. Now it's now sending me an email, which should have a link in any moment now. And when I click on that link, it will activate my account. And there we go. And I can now proceed to our console. It's going to ask me a series of questions. I'm going to treat this as a personal thing because that's simplest. I've got this silly name here. I'm going to give it a better project name. Again, it makes it easier to see what I'm doing. It's guessed my country is United Kingdom, which is correct. If you're in the States, it will try and guess your state as well. I'm already signed up to our newsletter, so I'm not going to sign up. You don't have to sign up if you don't want to. We're very careful to make sure that the option is that way around, and I'm now done. And that brings me to this page where I can create new services. So can everyone let me know if they're okay? I'm going to pause a moment. I'm hoping this was relatively simple. This is probably the point where I should ask if anyone actually has experience with messaging systems and so on here. I've used various wild and wacky things in their time, including, of course, RabbitMQ, which is a classic in the field and very good at what it does. One of the reasons that Kafka is different is because it does a much more restricted set of things very fast. It's designed, it doesn't have all the bells and whistles and acknowledgements and things that something like RabbitMQ has. Good, thank you. Sebi, are you talking or are you muted? You're muted.
I was muted, sorry. I just wanted to share one of my first projects was when I was a junior back in 2004. I was working on an integration layer and we were using MQ series from IBM.
Oh, yes.
Yeah. So,
I have colleagues who use MQTT a lot, and I very nearly got to use 0MQ. We couldn't use it because the platform we were working on didn't want to support C++, which is a pity because 0MQ looked really fun. Well, we ended up writing our own kernel messaging system like you shouldn't do.
Exactly.
Which was wonderful fun. Right. Okay, so I'm going to assume everyone is at that stage. So we're now going to create a Kafka service. Before I do that, let's point out that we have here Postgres, MySQL, and Redis. They all have free plans associated with them. So you can set up a Postgres, MySQL, or Redis service for free. We won't charge you and that will be free for the foreseeable future. We don't do that for Kafka because Kafka is rather more expensive to run. But let's go to Kafka. So I'm leaving this with Google Cloud. You can choose whichever cloud provider Google if you prefer. I'm in Europe, so I'm going to go with London because that's nearest to where I am. I've no idea if that makes any difference for my latency. Startup is the smallest plan, and that's going to be perfectly acceptable for what we're doing. Now, you'll notice at the right, it's telling me what plan I'm selecting and what I've chosen, and it's pointing out that I am indeed on a free trial. So that's not going to cost us anything, and it's not going to ask for any money from anyone, including me. The other most important thing to do is at the bottom, it points out you can't change the service name. So let's give it a better service name. You don't need to call it anything this long, but I get emails saying such and such a service is busy or has been running too long and things. So it helps if I have a service name that is very obvious to me what it is. So let's create the service and start a trial. And that should then come up with this page where it lets you do various configuration things. Now, this allows you to set up things that are rather more complicated than I'm interested in. So I'm going to come down to the left here where it says go to service overview and skip all of those steps. And that takes me to the overview page for this service. If we look at the top here, we can see there's a flashing blue 3. That's setting up the 3 nodes that are part of this cluster. And that's next to it, it says rebuilding. So what it's doing is it's creating that cluster for us. That's going to sit there for a little while. So we'll go away and do other things to let that build. But slightly further down, don't close this tab, because further down, we've got the information of how to connect to this thing. And we've also got the access key, access certificate, and CA certificate that we're going to need to create a secure connection. So I'm going to download those, and this will download them to my download folder, because we're going to use those in a little bit. So I would suggest you all download those now. We'll come back to this tab to copy the host and the port in a moment. So we go back here. We're now going to set up that connection. So what we will need is we'll need the host name and port, as I said, and those 3 certificate files. So we're now going to go to the Gitpod project that we're going to use. So Gitpod is, if you haven't used Gitpod before, it's a lovely tool that you can use that enables you, it's a Valentine's Google, to run your editor in the cloud. So in particular, it'll run VS Code. Now, please ignore this yellow warning I've got at the top. Gitpod are not unhappy with me. We're talking with their service people about this because that message shouldn't appear. They're not unhappy with me. I'm able to use this. We're not quite sure what's happening here. You shouldn't get that. You might need to log in with your GitHub account, and it will probably ask you permissions to say it needs access to GitHub, to the workspace that we're going to be playing with. You can see here it's saying that we're going to be working with the Aiven Labs Python Apache Kafka tutorial thing. And I'm going to accept VS Code as my editor, because that's a lovely editor, and the standard setup is perfectly okay. I'm going to click continue. You might still be working on getting in. That help page that I referred to earlier has information that, when I say I click continue, I didn't click it hard enough. I know this worked earlier in the day because I checked. And this will then open me VS Code, and you'll tell you're in the right place when down the left-hand side, you can see notebooks, SL certs, and what looks like a standard sort of GitHub project, all the files for that. I'm going to just go X on this dialog at the bottom because I don't want to open in VS Code Desktop. So again, let us know when you're sorted. The reason I haven't tried to go through the whole logging into Gitpod from scratch is it's quite hard to make Gitpod forget you enough to get back to the status where it doesn't know who you are anymore. So I've tried that, and it just leads to confusion. It's possible that that's how I've confused it enough to get that little yellow banner there. So let's not go there. Just for reference, you can also use the JetBrains IDE in Gitpod, and there's a rather lovely terminal mode if you're like me and like Vim at the terminal, which I used in a workshop the other day. So they're really trying to give you all the possibilities. You get, I think it's 10 hours a month or something like that for free, and it's really quite cheap to move up to the paid plan if you're using that. And it's very nice for demos because it lets us do things in the browser, regardless of how your machine is set up. And if we're working with something like Kafka, which is a bit of a pain to set up locally, you either have to start building stuff seriously, or you have to start using Docker containers. And even then, they're not that simple to get running necessarily. It's an awful lot easier to set things up with Gitpod and a remote service like Aiven. And you don't need to do anything except have your web browser and a couple of accounts. I'll give it another moment or two for people to get set up.
And maybe you can already increase a bit your font of the...
Oh, yes, I keep forgetting about... I have this bad habit of using a very small font size. So thank you, Sebi. I always forget that. Is that about right?
Yeah, that's good. That's good enough.
This is something I'd asked Sebi to do earlier on. I keep forgetting. Unfortunately, I haven't found a way of making Gitpod remember my font size, which is what I would ideally like. Can I make this side any narrower?
Yeah, you can. And the terminal, you can probably make it smaller as well.
I can make that lower. Yeah, that'll come in a bit when I get there, I think.
Yeah.
We're not going to actually need the terminal, I don't think.
No, we don't think. No,
we don't actually. So I can access and get rid of it.
You can just close it. Yeah.
Let's bring it back. Yes, that's the only. I have two very small grumbles about Gitpod, which are so tiny. One is I haven't figured out how to make it remember that I want my font size bigger, and I think there probably is a way. And the other is their terminal mode is a dark mode terminal, and I'm one of those weird people who likes light mode. It's not. It's such a tiny niggle. I think when you're niggling about things at that level.
No. But when you present, it's advised to use a light background.
Whilst I don't like dark mode, I think the terminal mode is one of the places where it matters less. Because the contrast can be good either way. But yeah, I like light backgrounds. But then I'm old school. Partly as a reaction probably to using very old terminals where you had no choice. It was green characters on a black background, and that was it. Those days ago. Right, I've not got any answers in the chat from anyone.
Yeah, you can go on, I think.
I'm going to go on. So the first thing we want to do is we said we'd need the certificates. We've got this lovely little directory here called SSL certs, which I've just opened on the left. And it says, copy here your certificates. So I'm going to go to my folder, my download folder. You can't see this. Select the 3 certificate files and then just drag them across into that folder. And there they are. They've appeared. You can see they're full of what you would expect from a certificate. This Kafka service won't be around after this workshop, so even if this certificate was useful to you from what you can see, it wouldn't help you. So I'll give you a moment to do that, and then I'm going to go up to the notebooks folder and open the first notebook. Now, I should point out that you can do all of this workshop offline later if you want. This GitHub repository is there. It's linked in the notes, and I believe. And did we link it in the notes actually? I can't remember if we did. It's this thing here. I will link it now just in case. I can put things in the chat as well. And I can't spell GitHub, so 1 second while I.
I put this link. So.
Oh, you did as well. Okay, right. Two at the same time.
Oh, the GitHub link. Okay.
Yeah. So if you want to go back and actually run the other, we're not going to get through all of the notebooks that are here on the left in this session. If you want to go back and run some of the others later, you can. So we're starting off with producing messages to a Kafka topic. So this, have you all come across Jupyter notebooks? this is a wonderful way of reproducing the idea of a science notebook where you write down all your experiments and what you're doing, mixed in with the idea of runnable code. So it's made up of bits of text and diagrams, plus pieces of executable code. And for each piece of executable code like this, when you press the little triangle run button, a tape recorder symbol for play, it will run that cell. So we're going to use this to run some pre-prepared code to demonstrate what we're doing. And the first thing we're doing, as you can see from the picture here, we're going to be a producer sending things to a topic. Now, to send things to Kafka, we need to know its host and its port. So we can go back to our overview here. And for me, my Kafka is now running. You can see at the top here, so that's good. So I need the host, which I can copy here. Go back to my thing, do my editing and put that in there. And we need the port. Same thing again, we get the port number. I'm sure if I had a better memory, I could have remembered that. But I like cut and paste because it's more, copy and paste because it's more reliable. Now, before we can run that, we need to tell Gitpod what Python interpreter we want to use. So if we go to the very top right here, we can see select kernel. And that's magic words for choose how you want to run your Python. So we want to use a Python environment. And we used to recommend using an earlier one, but we now know that this will run perfectly well with their recommended Python 3.12.1, which is good because that's a nice recent Python. So we select that. It's saying every time I open a notebook from now on, it's going to give me these, do I want to open various ports? I'm just going to X each of these because we're not interested. We're not doing anything with web apps or anything, so we don't care about that. So now at the top, I've got Python 3.12.1 is the Python I'm using. So I can now come down here and click on the run button. And we can see that's now got a number in the square brackets. So this is cell 1 and it's run. A tick to say it ran and how long it took. So that's good. So we've now set the hostname and port. All that was just setting up two variables. We need to install the Python library that we're going to use. The exclamation mark here says run, essentially run a shell command. So we're going to run pip install to install the Confluent Kafka library. So I'm going to click on that. That will take a moment. So Confluent Kafka is probably the most commonly used Kafka support library in Python. Confluent, I believe, was founded by the people who invented Kafka, so they know what they're talking about. It doesn't, so I like using AIO Kafka as well for doing asynchronous talking to Kafka, but Confluent Kafka library is an open source library. It's always a sensible and safe choice to go for, so that's what we're using here. And that successfully installs itself in any dependencies it has. So the next thing we're going to do is to set up our producer in Python. So we're importing JSON because we're going to use JSON later on. We're going to use JSON to set up the messages. We're inputting the serializing producer from Confluent Kafka. Now, Kafka events, what goes into the topic, are just chunks of bytes. Kafka has no knowledge about that structure. It doesn't care. You're giving it a chunk of bytes. It's then sending that along as an event. That's not very convenient for us. We want to create our Python. We want to take an object in Python. We want to encode it as JSON. We want to have it to be JSON because that's a lot easier to handle with. So we need to have a mechanism for saying, take my Python object and turn it into JSON and then turn it into these bytes. And we can tell the serializing producer, it does what it sounds like. It serializes our Python data into bytes. We can tell it to use a JSON serializer, and this JSON serializer is just saying, take our message, our Python object, turn it into dump it out as JSON, and then encode it make sure it's ASCII. So that will turn our Python object into something that looks like a string that starts with a curly brace and has JSON in it, ends with a curly brace. So we're basically dumping JSON out as ASCII. We need to specify where to find our Kafka cluster. So we give it the hostname and port that we saved earlier. We need to give it a client ID, which that's just a name for the client. Our security protocol, we're using SSL, and that means that we specify these three certificate files. So we're giving it all the information we'd got from earlier to connect securely. That means that if I push the little button, then we should be connected to Kafka. So there's a lovely warning here. You do not want to know how many times I have missed reading that note and tried to run the little bit of code after it without setting up a topic. So in order to write to a topic, there must be a topic to write to. When we created the producer, when we set up the Kafka, we could have set it up to automatically create topics. That can be very nice for testing or for demoing. It's not normally a good idea in production code because then you end up with typos leading to random topics that you don't expect. So we're going to create a topic by hand. And to do that, we could do that by various means. But we're just going to go back to the console here. This is the tab from earlier. If we look at this left on this side, yeah, I think everyone occasionally, Jane says she's done that too. I think everyone has done this occasionally. Go back to our on the left here, it says topics. And here it says create topic. It's telling us we haven't got any topics yet. We're going to create a topic. My very short memory makes me go back here and say we want it to be called pizzas. I can remember that long enough to type it. Now, there are other things we can enable here. We're not going to bother. We're just going to create the topic. So now we have a topic. We can see it's called pizzas. If we go to it, there's no data there. We'll come back to here. So here is how we send a message, an event to Kafka. And it's really simple. We just produce to the topic and we send our data. Now, sending a key is optional. If we don't send a key, Kafka will either will guess a key for us or we'll figure it out by various means. But sending a key and value is a very safe way of doing this. So we're sending here, we're sending an ID of 1. We're using the same ID as the key. We're sending the name is Francesca, which is my colleague who likes pizza and doesn't like pineapple on pizza and came up with this demo. And he's requesting a margarita pizza. Now, because we're serializing to ASCII, serializing carefully, we're actually safe to send the emojis there. Everything is fine. The flush function at the end just says to the library, make sure you send that message now. By default, I believe the library will batch up messages a little bit, just so that you're not sending message. That's a decision you have to make in terms of how bursty you want your transmissions to be. We don't want to do that. We're just going to flush the message immediately. So if I run that, it should succeed. Naught means it succeeded. That's great. How do I tell if it's worked? Well, I can come back over here. And if I go to messages, so I'm still in my topic. Let's actually start from scratch again to make this clear. So I'm still from my service overview here. I'm still in topics. I'm not doing well with my mouse today. Yeah, I selected pizzas. I can select messages. Now, Kafka communicates normally by a protocol. It sends bytes over the wire, but it also has a REST API, and the console here uses the REST API to talk to Kafka to find out what current messages are. So I need to enable that. Now, I can fetch messages, but first I'm going to say my messages are in JSON, so I'd like you to show them me as JSON. So all I did was at format, I selected JSON. Now I can come here and fetch messages. And after a moment, look, one message. And if I come over here and open this up, I can see it's my message with Francesco ordered a margarita, and there's the key as well. So we've proven we can send a message. Of course, that's not very exciting. It would be nice to send some more messages. So Adele is after a Hawaiian pizza with pineapple and I assume that's salami. And Mark is after a pizza with chocolate. I know Francesco will not get on with Adele because he thinks that pineapple on pizza is a bad idea. I'm ambivalent. I'm not too keen with sweet things with my meat, but I know my Finnish colleagues are very keen on Hawaiian pizzas. So if we run that, that sends both of those. And if we come back to our messages here, our overview here and fetch messages, we can now see we've got 3 messages. So the oldest one is Francesca, the next one is Adele, the third one is Mark. And those are indeed in the order that they were sent in, starting oldest at the bottom. So we've successfully produced some messages. Now, for a programmer, that's wonderful, but you kind of want to write the code that also receives the messages. So we'll have a look at that. I don't need this service cert thing. So I'm going to split this screen here, and I'm going to open the second workbook, which is about consuming messages. So you can see here, we're now going to be looking at the other end where the consumer is reading. So it's got all the same setup as needed. Now, I am going to cheat here because I had already put these in here. So I'm going to copy the hostname import here. Because this is an independent notebook, I need to copy these over here. So I'm going to have to do all my setup again. So those are in there. I need to select a kernel again. So again, we can select the same kernel. Again, I can get rid of these. I'm not interested in any other ports. Now I've selected my Python. I can run this, set the variables here. If you don't mind, I'm just going to shrink this left down a little bit. Is that visible to people? I hope that's okay. We need to install the
that's perfect.
Yeah, okay. We need to install make sure we've got the same library installed. That should be very quick because it was already installed. And now we're going to create a consumer. So if we go over here, here is where we created our producer. Can I make the Explorer go away? I don't know if I can. This is a lesson I need to learn from. Right, so if you look over here, we're importing JSON. We're importing the serializing producer on this left, on one side. Over here.
Yeah, if you click on the Explorer, on the icon, so more on the left, completely on the left. No, the small icon. Yeah, this one. Click on it. Can you click on it?
That.
Oh, no. On the. Oh, sorry. No, I thought you could click on the icon to make it away, but yeah.
I might be able to. This is where I didn't prepare.
Yeah.
There you go. That's wonderful. I didn't think it would be impossible because this thing's it's VS Code. So that's much better, I hope. So you can see on the left, we had our serializing producer. On the right, you might expect we have a deserializing consumer. So that's going to do exactly the opposite. It's going to say there is a chunk of bytes coming in. I want to turn it into JSON, and then I want to turn the JSON into Python. So this should probably be called a JSON deserializer. I'm not going to fix it now. So this does the opposite. The one on the left, the producer had a dump to string. This has a load from string, and it's saying, and I know that string was ASCII. I'm then reading it as JSON and loading that into Python. We have the same arguments for how to find a Kafka server. We've got the same client ID. I don't think that matters. We're going to ignore the group ID for the moment. And we've got the same security setup. So then we create a deserializing consumer. So we run that. And then we're going to read messages from the pizza topic. So let's try and read some messages. So if we run that, you can see that's going round and round because here we've got a loop. So what it's doing is it's subscribed to pizzas, and then while it's running, it's trying to poll to see if there's a message. If there isn't one, it continues. If there is, it reads it in and then prints out the information from it. And that's not doing anything. And the reason that's not doing anything is that we started reading from the end of the topic. So there aren't any new messages there. If I go over to we could have chosen to read from the oldest message, but that's not that common a choice. So if I come over here and let's make this tips, just to prove a point. If I now produce a message with that, then here at the bottom, we can see we've read ID1 name Tibbs. So we've read a message. And if we come down here and produce some more messages, we can see we've read them. And of course, just to prove the point, if we come over here and fetch messages, this consumer, because of course that's what it is, we can see these are the messages it read earlier, Francesco, Adele, and Mark. Then there's the Tibbs message, and then we've got Adele and Mark again. So those two consumers are entirely independent. One was reading from a while back and has carried on, and this other one has been reading only the most recent messages. And that's actually all we have that we were planning to demonstrate. I will stop this. So the way to stop this is to go and press the little square icon, I believe, because otherwise that will loop forever, and that's a bit cruel. Now, I went past this, this thing at the beginning. You remember I mentioned earlier that you could have multiple consumers reading from the same topic. If they do, then they share a group ID. So the group ID is a name that says we are sharing reading. That will only work if you've also got partitions. When you create a topic, by default, it has one partition, but you can make it have multiple partitions. Kafka will then either organize splitting up the messages into partitions for you, or you can tell it how to do it. And then if you've got two partitions and two consumers in the same group ID, they will each read from one partition each. So that's how you split stuff up. You might guess from that balancing your partitions so that you have a reasonable number of messages going to each partition, and not all of them going to partition 0 and none of them going to partition 1, becomes something you have to think about. And that is indeed a little bit of Kafka science that one could get involved in. By default, if you let Kafka do the job itself, it should in general make it go reasonably well for the simple sorts of things one's doing in learning things. So if we go back to here, we've produced data to a topic and consumed data from a topic. So we've learned a little bit about Apache Kafka. We've learned how to create a managed Apache Kafka cluster. We are at least consistent on our typos. We've securely connected to both to produce and consume messages. We're a little bit early on time. I could chat about other things, but if you would care to give us feedback, that's immensely valuable. You can follow this link or use the QR code. Feedback helps us improve by telling us what we can do better in the future. I am going to put a link into the chat, which is a link to the original paper that I came across found about Kafka in. This is a paper which explains why Kafka was of interest to LinkedIn. It talks about how they got the idea of Kafka as a unifying principle that you could use for communicating when you need to share data between lots of systems. Because the traditional way that one would do this would be to write stuff to a database and then have all the people who care about the data in the database poll the database to find out what information they needed, which causes a lot of load on the database. Then you get other systems start talking to each other to find out the data they want, and you end up with a tangled nest of connections. The inspiration that the creators of Kafka had was that actually you've got a series of events, and if you make it so that it's easier to produce events onto a shared event queue, and then read events off as you wanted them, then you could take events off of the database, you could take events off for your statistics collection, you could take events off for your responding to customers, you could take events off for your accountancy. Those could all be independent using a common sort of source of truth, which was this linked set of events. Beyond that, we get tools like Flink, which allow you to say, well, I only want to take some of the events, and I only want to take some of the information out of the events, and that allows you to then select information out and create a new topic, a new sequence of streams that has those amended events. And we will hopefully do a session in the future where we'll explain how to do that sort of thing. But if not, there are a lot of tutorials out there, and there are tutorials on our developer Center as well, talking
Yeah.
about how to do. That's the link.
I just shared the link.
And I will go back to my slides because I have more links in here. Another thing I should mention, just because I'm quite enthusiastic about this and I can't go, I'm really unhappy. If you're anywhere near New York City at the end of the month, we're having a free event for anyone interested in the sort of stuff that Aiven gets used for. So not Aiven, but the world of the people who might use Aiven. Anyone who's working with distributed event data or distributed data at all. We've got Kelsey Hightower and Rita Giotti talking, and quite a few other people as well. It's going to be incredibly exciting and rather good. I'm so envious. I'm on the wrong side of the Atlantic. Jen's going to be there. She will report back, and I will cry about missing it. You can register using that QR code or follow the URL. This is our. I'm sorry, it's impossible to click on these. So upcoming workshops, we're now at a twice a month cadence for our workshops. The next couple of workshops will be a 2-hour workshop, one on APAC friendly time and one on European and North American friendly time, like this one, about doing using machine learning and PG vector with Postgres to create a little app that will let you find movies by typing in a bit of text about what you like about the movie, and it will then use machine learning to look up the correct to look up interesting movies for you. And that's using Node.js. I've done the workshop once with Elena, who created it, and it worked very well. It was very interesting.
Yeah,
we've got those two of those, and then at the end of March we're hoping to do an extended version of this workshop where we'll hopefully get into a bit more in depth of actually doing something beyond just sending messages with Kafka. The Aiven newsletter we saw earlier, you had the ability to sign up to that when you created your services. We promise not to spam you with much information. On the left is the Aiven community forum link where you can go and ask questions pertaining to Aiven itself, but also of anything related to how we do things. The bottom left, you've already seen the Developer Center where we have interesting articles about stuff that might be technical stuff, and the feedback form. Thank you for joining us here. I hope that was useful, and we hope to see you another time in the future.
Thank you, everyone. Bye-bye.